Example 14, making an angle. This one, we have a ball. This ball should be a conducting ball. It means that we may use a table tennis ball and then on the surface with a aluminum foil. Is in elastic string. Okay, it means that to isolate this ball. And then in between two parallel plates connected to the EHT supply. And finally, we can see the angle 20 degrees. Okay. Okay, first part, what is the electric field between the metal plates? Once again, this one is the metal plate. In order to find out the electric field strength, you should use the formula V over D. But here, we haven't any V or D, just only know that the angle. Then this one is a mechanics problem. Okay, between it, we have mg, will be the weight, and also we have the electric force. What is the electric force? Look at this again. E should be depends on V over D. But what's V? What's E? Should be force per unit charge. So in this case, in order to find out the electric force, you can use field strength times the Q. It means that this one, QE. And also because the string is inclined to a certain angle, we can resolve the component of it. Once again, in mechanics, you should know that you should find out the largest one, the largest force. In this case, the largest force should be tension T. Tension T, it has two functions. One is the vertical part, the vertical component to balance the weight. The other part is the horizontal component to balance QE. Finally, we can set up these two equations. Vertical one, mg, should be T cosine 20 degrees. For the horizontal one, should be QE. It means that the electric force, okay, should be equal to T sine 20 degrees. Afterwards, we have the equation 1 and equation 2. Then what should we do? Using the mathematical skills, divide it. Okay, equation 2 divided by equation 1. Then you can get tangent 20 degrees and this. Because this part, the question, we want to find out the field strength. You know that M, G, Q, and angle. Then you can find it out. Part B. If the plates are 50 meters apart, what is the applied force, applied voltage? Should be this equation. The last part, part A, we know that E. In this case, we know that D. Then we can find out V. Should be this. What if question, part A? Where would the angle between the fat, it means that the string, and the vertical change if we move the hinge P a little bit towards the left? It means that the whole thing move it to different position. The answer is not. Remember it, between the parallel plates, the field strength should be the same. Same electric force, same weight, then the tension should be the same. The tension will make the same angle, so no change at all. Part B. Would the angle between the fat and the vertical change? Okay, if we move it to the right hand side, the same. Okay. Okay. This one. Move to the plates on the right. Okay. A, but further away. This one may be, okay. I'm not sure. Maybe this. Initially should be here. Now we put it here. Okay, then what will happen? Because we have the edge effect here edge effect. For example, this one is positive, negative, edge effect. This one is the E field. If we have the edge effect near the edge, the field strength will be smaller than before. Okay, look at this diagram. Mg, no change. But if this electric force, no, in this case, from positive to negative, in this case, QE may be smaller. If this one is smaller, then what will happen? This tension should not need to be greater, should be smaller. Okay, but how to know that? You can use the mechanics method to do it. Mg keep the same. QE, original one should be this, but now may be smaller, like that. If like that, then the tension, the new tension should be this one. The original one tension should be this. Graphically, you can see that original one should be longer than the update one, okay, the blue one. So this one, the value of the tension should be smaller than before. And also, how about the angle? Original angle should be this angle. The new one should be this angle. You can see that the angle will be smaller than before. Okay, next one. Example 15. Also the parallel plates. We put an oil droplet between it. And also this oil droplet must be charged, otherwise, due to the gravity, this one will drop down. But the question tells us that should remain stationary. Okay, and also the separation between the plates is 5 mm under EXT. The voltage given is given to you. If the droplet, the radius of it is this one, the density is this. Remember what is the density? It means that mass over volume. Now this one, calculate the magnitude of the net charge. Because this one is also a mechanics problem, we have the weight mg. But now we can keep it here. It means that you should provide the same magnitude upward force to balance it, like that. So you should consider the weight, what is mg, what is the upward electric force. Electric force should be QE. Once again, this one, definition of electric field strength should be force per unit charge Q. Then the electric force should be QE. In this question, in this part, we want to find out Q. You know that M, you know that G, but I don't know what is E. We have the other formula for parallel plate, should be V over D. Okay, you can put V and put D in it. After your calculation, you can find out this will be the charge on it. Part B, if the large net charge carried by the droplet is negative, okay, determine which plate is positive. Now on the diagram, if this one is negative, without any force acting on it, we have the weight, this one will drop down. But now we want to keep it the same position. It means that you should provide a outward force to attract it outward. In order to attract a negative charge, the upper plate must be positive. On the other way, means that the lower part should be negative. Okay. And the other method is this one. E field pushes up an electric charge. It means that the E field should be pointing downward. E field should be starting from positive plate, then the upper part should be positive, the lower part should be negative. Next one, when we deal with negative test charge, think about both the attraction or repulsion by the sources, the force on a point charge to see if it is opposite to to the one on the negative charge as a double check. Okay, next one. Next one will be the work done, okay, by electric field. Okay, stop here.